See this one, an instruction pipeline. This question is asked in GATE 2000. It is having A part and B part. Now we shall see A part. Later we shall see B part as well. First we shall answer this here. An instruction pipeline has 5 stages where each stage takes 2 nanoseconds. So it is a 5-stage pipeline and each stage is taking 2 nanoseconds to complete. And all the instructions use all 5 stages. Therefore every instruction you should consider that all the 5 stages are required. Branch instructions are not overlapped. That is, the instruction after the branch is not fetched till the branch instruction is completed. So what is that they are saying? If you have 5 stages, S1, S2, S3, S4, S5, in case if this is a branch instruction, then they are saying that we will not start the next instruction until the execution of the first branch instruction. Therefore, coming to the branch instructions, one instruction will be coming out every 5 clock cycles. Got it? For the non-branch instructions, you can consider that the instructions are coming out 1 clock. Clocks per instruction is 1, but in case of these branch instructions, you should consider that the clocks per instruction is 5, right? So 5 clocks are required for the branch instructions. Now, under the ideal conditions, calculate the average instruction execution time, assuming that 20% of the instructions executed are branch instructions. Ignore the fact that some of the branch instructions may be conditional. So they are also saying that out of these branch instructions, some may be conditional and some may be unconditional, but you can ignore the fact that some of them are conditional. The reason why they are saying us to ignore it is, in case if it is a conditional branch, there is a chance that we might not incur this penalty at all the times. Sometimes the penalty will be there whenever the condition happens to be true. Sometimes the penalty will not be there if the condition is false. So we have to actually analyze it separately, but they are saying that don't separate those cases. Always assume that for every branch instruction there will be penalty, and so the number of clocks for such instructions is 5. Under that assumptions we are supposed to calculate it. Okay, and they are saying that 20% of the instructions. So they are not asking us to find out the exact time, they are asking us to find out the average time. Why? Because they have not given us how many instructions are being executed. Let us say n instructions, totally n instructions are being executed, and out of these n instructions, 20% of the instructions are branch instructions and 80% of the instructions are non-branch instructions. Based on that assumption, we can go ahead, right? So let us assume that there are n instructions, and let me first find out the total time. If there are n instructions, 20%, which means 0.2 of the instructions are going to take 5 clocks, right? 5 clocks, and each clock is actually taking 2 nanoseconds. How do I know that? Because they are saying that each stage is 2 nanoseconds. Each stage means it is nothing but each clock. You can think of it that way, right? So 5 stages are required, that is why I am writing 5, and each clock is actually 2 nanoseconds. So 2 into 10 power minus 9 seconds plus the remaining instructions. How many instructions are remaining? 80%, right? So n into 0.8. For the remaining instructions, it is going to take only 1 clock per instruction. Got it? And we know that the clock is 2 into 10 power 9 again. This is the total time, but then they are asking about the average instruction execution time. So on average, what is the time? If you have to find out the average, you divide it with the n, which is the total number of instructions. So n will live, right? And I think you can do the remaining. You can just do the math and find out how much it is. Okay, so that is the average instruction execution time. It will be roughly more than 2. In general, if you don't have any clocks like this, if you don't have any branches, then what happens is you are supposed to get out one instruction every 2 nanoseconds, and so average execution time will be 2 nanoseconds. But because there is this particular branch instructions, it has to be roughly more than that. So if you want to find it out, so this is nothing but 1. 5 into this one is 0.2 is 1, right? and this one is 0.8 into 2, so 1.6, right? So it is 1.6 plus 2, it is 3.6, I guess. 3.6 into 10 power 9, so which is 3.6 nanoseconds, right? You just cross verify it. I'm just thinking that it is that, okay? So you just check it. But anyway, what I mean to say is, without branch instructions you are supposed to get 2 nanoseconds, but because of the branch instructions, because of that penalty, we are getting 3.6 nanoseconds per instruction, correct? So why do you think that it is actually nearly doubled, even though there are only 20% of the instructions which are branch instructions and 80% of the instructions are non-branch, right? Why do you think that the execution time has nearly doubled? The reason is the penalty is very high. In this case, you are actually getting out one instruction every 5 clocks, right? So that is the reason it has nearly doubled. Even though this 80% are taking only 1 clock, it is taking 5 clocks. Yes, there are very less number of instructions, but they are taking more clocks to execute. So that is why the average has increased very nearly double. Okay, fine. This question is continuation to the previous question, where we have seen that in part A they have given some instructions and some of them are given as the conditional branches. Now this is just the continuation to that. Read it. If a branch instruction is conditional branch, the branch need not be taken. If the branch is not taken, the following instruction can be overlapped. When 80% of all the branch instructions are conditional branches and 50% of the conditional branches are such that the branch is taken, calculate the average instruction execution time. So if you observe this, the problem with these questions is the statements will be very long. You should really have patience to read the question. Once you read and understand the question, solutions will be easy. See, in most of the cases it so happens that when the question is very long, generally the solution will be very short and simple. Okay, so in this one what they are trying to say is, I'll just show you what exactly they are saying here. See, in the question number A, they have already told us that out of all the instructions, 20% of the instructions were branch instructions and 80% of the instructions are the normal instructions, let us say non-branch instructions. And now they are saying that within these branch instructions also, some of them are conditional branches and some of them are unconditional branches. So they are saying that 80% of the branch statements are conditional, and so 20% of the branch statements, see this, among these we are talking about it, okay, are unconditional branches. Okay, and whenever it is unconditional branch, definitely branch will happen, irrespective of what the condition is. Definitely branch is going to happen and we have to pay the penalty. And since they didn't mention anything about the penalty for the unconditional branches, you can take this as the given penalty only, right? So in this case penalty is going to be 5. So for the non-branch instructions, we know that CPI equal to 1, clocks per instruction is definitely going to be 1, right? So in case of branching, there are 2 types of branch statements. One is conditional and other one is unconditional. In unconditional branches, we can consider that clocks per instruction in case of unconditional branches is going to be 5 because there is no overlapping. But then coming to conditional branches, there are two types. One is branch is taken and branch is not taken, right? For some instructions branch is taken and for some other instructions branch is not taken, right? So in case if branch is taken, then the clocks per instruction, right, they are saying that 50% of the instructions of the conditional branches branch is taken and 50% of the conditional branches instructions branch is not taken. Now when branch is taken, then the penalty, because of the penalty here also clocks per instruction we have to pay 5. But when branch is not taken, that is what they are saying, when branch is not taken there is no penalty, we can run with overlapping, therefore CPI equal to 1. So try to understand this one. Now with this particular this diagram, you can analyze the question. If a branch instruction is conditional branch, the branch need not be taken, which means if a branch instruction is conditional branch, the branch may be taken or it may not be taken. If the branch instruction is not taken, if the branch instruction, see branch instruction, it is a conditional branch, and if the branch is not taken, right? If the branch is not taken, the following instruction can be overlapped. So since the following instruction can be overlapped, there is no need of penalty here. That is why clocks per instruction is going to be 1, right? When 80% of all the branch instructions are conditional branches, which means out of all the branch instructions, 80% are conditional branches and 50% of the conditional branches are such that branch is taken, which means out of these conditional branches, branch is taken 50% of the time. Therefore branch is not taken for the remaining 50% of the time, right? Then they are asking, calculate the average instruction execution time. There are various ways to solve it. You can assume that the total number of instructions are n, and then find out how many instructions are falling in each category, right? And then assign these many clocks and multiply with the clock time. I think 20 nanoseconds is the clock time there, right? I think 20 nanoseconds or 2 nanoseconds, I don't remember it. Okay, so let's say 20 nanoseconds is the clock time there. Now the continuation is, you have to find out the total time and divide by the total number of instructions, assuming that the number of instructions is n. Other method of solving this one is, the other way is, you can assume that totally there are 100 instructions and you can continue with it. Let us say the total number of instructions are 100. So whenever these percentages are given, it will be very easy if you assume that the total number of instructions are 100, then you can easily count it. Now say this, out of 100 instructions, you can think that 20% are branches, therefore 20 instructions will be branches, and 80% are non-branch, which means 80 instructions are not the branching instructions, right? And after that, since 20% are non-branches, which means we have only 20 instructions now. Out of these 20 instructions, it is very important, out of these 20 instructions, 80% are conditional. So what is 80% of 20? It is 16 instructions, which means 16 instructions will be conditional and the remaining 4 instructions will be unconditional. Are you getting this? Don't apply this 80% to the 100 instructions. Out of these 20, 80 are conditional and 20 are unconditional. Therefore we got 14 instructions and 4 instructions here, right? And now out of these 16, 50% are branch taken instructions and 50% are branches not taken instructions, which means here we are going to have 8 instructions and here we are going to have 8 instructions, right? So now you can analyze this. Out of 100 instructions, 20 instructions are no branch instructions. Therefore for this 80 instructions are no branch instructions, so the number of clocks required is 20 into 1, 80, right? Out of this 100, 80 instructions are no branch, therefore 80 into 1 clocks, right? And then 8 instructions are having a penalty of 5 because these are conditional branches where the branch is taken. So for that particular 8 into 5, this is the clocks. And for these 8 instructions, there will be no penalty. That is why 8 into 1. And for these 4 instructions, which are unconditional branches, they didn't mention specifically what is the penalty for unconditional branches. Generally, for unconditional branches, the penalty will be less compared to the conditional branches. But since nothing is given, we have to assume that even for unconditional branches also, the penalty is the same as 5. So that is why 4 into 5, right? So just check this, 80 plus 8 plus 8 plus 4, totally it is 100. So now we have to add it. So it is going to be 80 plus 40 plus 8 plus 20. So if you add it, I think it is going to be 148. So 148 clocks are required for this program execution, right? But then we assume that the number of instructions taken is 100 instructions. Now we have to find out the average clocks, which means the number of clocks per instruction. Therefore you divide it with 100, then we get number of clocks per instruction. Then the effective number of clocks per instruction is 1.48. Then what is the question asked here? Calculate the average instruction execution time. So 1.48 is in the terms of the clocks, but then it is if you have to convert it to the clocks, you have to multiply with the clock period. I think the clock period is 2 nanoseconds or 20 nanoseconds, I don't remember it. You multiply it appropriately from question number A, you are going to get this. I hope you understood how I analyzed this one. Initially they are given that out of the total instructions, some percent are branch instructions and some percent are non-branch. And out of this branch, some percent are conditional branches and some percent are unconditional branches. And out of these conditional branches, some percent of instructions are going to be branches taken and some of them are going to be branches not taken. So if you try to evaluate the using not using 100, here I have evaluated using 100 so that it will be easy for you to see it. If you try to evaluate it directly, then you have to think of it like this. If n is the total number of instructions, initially here they will be 0.2 into n, and here they will be 0.8 into n. And then now you have to take this 0.2 into n and then find out 80% of it, which means 0.2 into n into 0.8, right? And here also 0.2 into n into 0.2, and then after that you have to take this number 0.2 into 8 into n multiplied with 0.5 in order to get the number of instructions here, multiplied with 0.5. You have to be very careful while you analyze all this. Once you get this diagram right, you can analyze it anyway and there will be no errors. Okay, so in most of the questions what happens is they will be asking in case if they want to confuse you, they will give you that unconditional branches are going to be evaluated faster, which means they will say that for unconditional branches during the decoding phase itself, which is the second phase, we'll find out the target address. Then here the clocks per instruction for those unconditional branches should be 2 in that case. Got it? So they will be a bit different, depending on the question. You have to go with that. Sometimes they will give you some number here. Okay. So anyway, this is how this is the most complicated question they might ask you coming to this conditional branches, and all the other questions will be easy. Sometimes instead of saying that the target instruction address will be known after the second phase or third phase or fourth phase, they will say that because of the conditional branches there are so and so stalls. Let us say they say there are 2 stalls. Then what does it mean? Next instruction should wait for 2 cycles and then start here. Therefore the clocks per instruction is going to be 3 in that case, right, in the way how we analyzed it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year, and in India the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.